Thank you very much, and thanks, Lab, for making me feel important. Hello, everybody. So my name is Dario. You probably heard that. I come from Italy. So this is how Italy looks like. And for any reason, the presenter plays some strange tricks, but don't worry, we're back. So this is Italy, and I live near that red dot. And I usually don't wear shirts, but today I am because a friend of mine told me that on the other hemisphere, that is actually here in Italy, you don't even see it because it's actually too far away, things are upside down. So I decided to do something I usually don't do and wear a shirt. I do stuff with code, as Lab told you, and mostly stuff with open code. So that's the reason why I'm here. Basically, I'm contributing to KDE, Qt, and telepathy. And today I want to talk about multithreading in Qt. So the first question which might come to your mind is why? So how many of you are Qt developers here? Raise your hands. Most of you. But for those of you who aren't, maybe when you think about, wait, presenter, are you okay? Okay, perfect. When you think about Qt, usually the first thing you think about is a UI toolkit. This is true, but Qt offers so much more than that. It's an application framework, fully fledged, providing a lot of features. I just listed some of them: networking, file system I/O, unit testing, dbus, an event framework, and of course multithreading. And most of all, it's completely cross-platform. So Qt is a great choice also for applications we are deploying on a console or applications without a UI. And it's a very good choice for UI applications, of course, because you get all the additional goodness. So Qt developers here probably know about Qthread. That's the main thing you use for instantiating a new thread on Qt. So should you use it every time? Well, the answer is no. And I mean, if it was yes, probably you wouldn't be here and I wouldn't be here most of all. Qthread is usually very useful for handling complex logic in a separate thread, which means if you're doing something small, something which doesn't require a full event loop, you should not be using it. And most of all, Qthread can be very dangerous because it's very easy to be misused when you subclass. I will not tell you why now, but I want you to keep that in mind, and you will give me the answer at the end of this talk, if you understood everything. So, I want to talk first of all about the other ways we have for creating threads in Qt and for taking advantage of that. Why do you do that? Anyway, the first class we want to take a look at is Qthreadable. Qthreadable, unsurprisingly, is a pool of threads. Guess what? Why a threadable? A threadable is extremely useful because it reduces thread creation costs. This means we can reuse threads we already created. A threadable is able to hold a number of threads arbitrarily, but also Qt has this awesome feature which creates a thread pool based on how many threads your processor optimistically supports. So if you have 4 processors, you will be getting 4 threads in your thread pool, or 5, depending on what your processor advertises. And it's flexible and configurable, because you can obtain threads from the thread pool, you can resize the thread pool to your liking if you need more than the threads that your processor provides. For example, I had to do an appliance one time in which I required at least 3 threads to be running, and I use a thread pool configured with at least 3 threads. So it's very useful in this regard. And the second class I want you to take a look at is Qrunnable. Because of course Qthreadable on its own is not really useful. I mean, it just gives us a pool of Qthreads. Qrunnable instead, if you're familiar with Java, probably, I mean, you know the runnable thing in Java. Well, surprise, surprise, Qt is very similar, almost identical actually. So the text is slightly cut out, we can live with that. This is how a Qrunnable based class works. You can subclass Qrunnable, and you have a run, pure virtual function you have to re-implement, much like Java. But what's the catch here? The catch is that this is how you use a Qrunnable. So I explained Qthreadable first for a very reason. Qrunnables are capable to be run from a threadable. Now, global instance returns the global thread pool, which is set up always, every time you instantiate a Qt application. This doesn't mean that a Qt application spawns multiple threads. A Qt thread pool creates threads when it needs to. Most of all, they are not deleted, as I told you before, and can be reused. So in this case, if we're getting this from like a main function or the very first line of our program, a new thread will be created and will be kept in the thread pool after the runnable actually finishes its work. Most of all, the runnable gets owned by the Qt thread pool. This means that the runnable will be deleted when it ends. This is a very interesting feature because you can simply shoot and forget. So why QRunnable? You have all the goodness of Qthread if you have been using Qthread in a very basic way. So you have the run function, it runs in a separate thread, but you can use Qthreadpool and get all the goodness for that. So if you have to repeat the same operation a lot of times, you can use QRunnable and get a performance increase because, of course, you will not be creating a thread and de-instantiating it every time. It's basically a cleaner and more efficient approach. But this is not so interesting. I mean, you have seen this in Java, you've seen this in many other languages. So I want to show you something which is way better. It's called Qt concurrent. What is Qt concurrent? Qt concurrent is basically Qthreadpool and QRunnable in a high-level fashion. So Qt concurrent is a high-level API which takes advantage of these two things for creating something extremely easy to use and extremely powerful. It's extremely useful, especially when you have to perform the same operation on many elements, which I'm sure all of you do in your applications. So this is something which is very interesting to know, even if you're not considering threading at the moment. What can it do? Basically, it does two operations, mapping and filtering. Mapping is useful for performing the same operation on many elements. Filtering is useful for obtaining a filter out of a list. In addition, it supports two features. Reduction. Reduction makes the concurrent operation squash all the results in a single value. And you will be the ones deciding how this happens. I will show you later. And block is meant to process synchronously. So this means that this goes beyond the multithreading scope. It can be very useful for optimizing loops, for example. So let's see a basic example. I'm very sorry for the first letter cut out. So we have a function, let's call it all lowercase. So this function, we will just pretend it returns true if the word is actually all lowercase or false if it's not. And we're getting a string list from somewhere. So what happens here? Qt concurrent is actually a namespace. So filtered is simply a function you can call. You can see that the syntax is very simple. You pass a list as the first argument and a function as the second argument. What happens? This Q feature here is basically your asynchronous return value. You can monitor this feature and get the result when it's over. What happens here? So all lowercase is called using all the available threads in Qthreadpool. This means that all of the available threads will be used. And this is also why Qthreadpool instantiates itself by using a number of threads, which is very close to what your processor best supports, because this is done for you already. So strings is processed asynchronously based on the number of threads you're using. And QFuture, with QFuture Watcher, which we'll see in a moment, is going to send a Qt signal when your result is ready. So you simply have to shoot your Qt concurrent and wait for Qt to notify you that the process ended. What are the killer features? There is much more than that, and I will show you now. It accepts function objects. So this means that you can create your function object and pass it to Qt concurrent instead of the function. It accepts bound function arguments. What does it mean? If you are using, for example, boost for binding a function to its arguments, you can use that and pass the boost bind return value to Qt concurrent. It will be accepted as a function as well. It accepts member functions. And this seems something stupid, but you will see in a while how useful it can be when you add a little bit of fantasy to your Qt concurrent magic. You can use iterators. Instead of passing a list, you can pass two iterators. This is not very relevant, but most of the times you don't want to pass a list around, but you want to pass a constant iterator instead. And most of all, it has QFuture's full flexibility, which we're going to see in a minute again. So let's run through all these examples to find out why I said these things. So this one shows how interesting it can be to use member functions. In this case, with 3 lines of code, you're filtering from a list of images all the images which are on grayscale. 3 lines of code, actually 2, because I had to go on a new line just for space reasons. So this shows you 2 things. The first thing is that you have no reasons for not using it. And the second thing is that it's very useful in synchronous environments as well. Because instead of having a full-fledged loop, you simply have a single function call, which does everything you need. So if you had used filter blocked, you would have get the same result, but in a synchronous way, so threads would have not been used. Let's see something more. This is a very neat trick. for getting, instead of a queue feature holding a list of values as a queue feature. So what we are doing here, we are using the reduced capability of Qt concurrent. Reducing the value means that a function is being called to merge all the values which are being filtered. And in this case, we are taking advantage of the feature of passing member functions. So what's happening here? Now you should be actually familiar with the syntax, but there is a third argument. The third argument is the function which is called for reducing the list. This function is called every time, and basically it's passed, we will see later, the list itself that is going to populate, or the type, because I won't spoil you anything about the next example, and the values it's going to insert. So in this case, we are inserting stuff into a new queue set. Result is that the queue feature is going to hold a single value, which is going to be our list. Now this seems like a neat trick for showing off and see, I can use Qt. But actually, it gets more interesting when you do something like that. Reducing doesn't mean, you can reduce to a list, but you can reduce us to a single value. What about that? We have a function which is in add to call age. So basically, what we are doing is creating a new queue image with all the images we've been filtering. So again, we are using the same filtering of is grayscale to find basically a union of all the images which are grayscaled. Our function is basically taking as a first argument the result. So the result is actually this, the template of queue feature. And as a second argument is the image we want to add. So this function is called every time we are adding something to the result. So in 2 lines of code, you basically created a new image, except for the function, which of course you have to implement anyway. But this shows you how incredibly powerful it is, also when it's not being used in multi-threading environments, because it's really something which can make your code cleaner and perform way better in multi-threading environments, of course. So it's really something that everybody using Qt should know, and it's one of the most hidden features. Hello? So I mentioned queue feature watcher before. Now, of course, queue feature is basically a return type, but you should know how to handle that. The catch here is that queue feature is not a queue object. Queue object, of course, like any other base class which provides meet object features, signals, or slot, has an overhead. And as I told you, Qt concurrent can be used without multi-threading. So in this case, why queue feature should be a queue object? No reason for that. But queue feature watcher is a queue object. So what happens? Queue feature watcher is able to send a signal whenever a result is available. Whenever the queue feature is finished, it can even signal progress. So you can even use Qt concurrent for doing fully synchronous operations, because a queue feature watcher will notify you every time a single item will have been processed, if you want. Or you can simply wait for the result to be over. And it's a full wraparound queue feature. So basically, queue feature watcher is also able to provide results. And another neat feature of queue feature is another subclass, which is queue feature synchronizer. What does it do? This thing is not very useful in multi-threading environments, but it's extremely useful in synchronous environments. So suppose you want to start many Qt concurrent operations, and you want to have everything settled by the time all of them are finished. Queue feature synchronizer does exactly that. So you can add a number of queue features to a queue feature synchronizer. And it's guaranteed that this synchronizer will return from its waiting function just when every watcher filter is actually over. So by the time the synchronizer has ended, everything has ended. So you can use this for synchronizing multiple operations and pretty much anything where you need to be synchronous when doing multiple operations. Of course, when talking about multi-threading, this is not very useful, but as I said, this is actually very useful for single threading environments as well. And I think this is slightly better than what I showed you before. And this is something that I guess all of you can implement in their applications. And maybe you never thought about it, but now that you know it, you should. So for now, I just want to switch to something slightly different, which is locks. Now, the usual reaction when somebody talks about locks is, ugh, or something close to that, because they're extremely boring and extremely dangerous. But somebody has to do that, and it's probably us. So let's have a look at them. The 3 basic locks in Qt are a mutex, I guess everybody knows what it is, a semaphore, same thing, and a wait condition, which is basically nothing but a semaphore with a condition. So it's not about the number of resources, but when a specific condition is satisfied. But there is more than that. This is a very neat thing. It's called key-read-write lock. Don't know if anybody if you use that. Key-read-write lock, it's sort of a mutex, because it's actually it acts very much like that. But its capability is to protect resources with read and write capabilities. So we can selectively lock one or both features at time. And we can create it in recursive mode, and we will see later why this is useful. So this is the scenario where you want to have a queue read-write locker, and if you have a mutex, probably you are suffering a lot of pain. When you have an object which goes through frequent concurrent reads and very few concurrent writes. Now the API of queue read-write lock is very, very easy. It's very similar to mutex, so you have a lock function, but in this case you have a lock for read and lock for write. What does it mean? That you basically can always check if one of the two features is available and block your function or do anything else if that specific feature is not available. And this is great because it can be used in single-threaded environments as well by creating it in recursive mode. So this is, for example, incredibly useful when you have a file you want to protect from reading or writing at times. So you can lock your file for writing while you do that. And you can simply check it without having your thread being stuck in a deadlock, because of course, if it was a full mutex, you would get a deadlock if you were going to check the lock here. But in this case, creating it in recursive mode basically uses it as a simple lock for read or write capabilities in any resource. And then there is this very neat thing which relieves some of the pain for using mutexes, QMutex locker. So, sorry for that again. Okay, why QMutex locker? Not this one, but this one. So this is a standard thing you do with mutexes. You lock your mutex in at the beginning of a function, and then you have multiple exit points. And every time you have to exit, you need to unlock your mutex. And basically you have to clutter your code with mutex declaration, and you know what happens? Yes, of course you do. You forget one of those, and your application goes nuts. This is not something which should happen. And this is why QMutex locker is very useful. QMutex locker is basically based on resource initialization as acquisition. So what happens? Basically, when we create a locker, we pass a mutex to it. When it's created, the mutex gets locked. When it's destroyed, the mutex gets unlocked. So at each exit point you're going to, your mutex is going to be unlocked all of the times. So compared to what we had before, we saved a lot of instructions we probably are going to forget when we add another case to our switch. This happens all the time, at least to me. So that's pretty much it for locks. But, I mean, do you need locks? That's a question that many people do. There is something which is called lock-free programming, which is getting very buzzwords these days. What is it? It's basically something based on Q-atomic in Qt. I'm not a computer science professor, so I asked Wikipedia to tell me what is atomic operations. So in concurrent programming, an operation is atomic if it appears to the rest of the system to occur instantaneously. What does it mean? I mean, what is it? Well, we'll see later. But Q-atomic basically wraps an integer or a pointer and allows to perform atomic operations on them. So basically, it's more a wrapper around a specific type than a class on its own. Why should you be interested? I mean, I am interested, but I don't know if you are. So I'm trying to convince you. It's extremely faster compared to a lock-based solution. It can be extremely faster if you're locking your resource a lot of times. We did some benchmarks in basically a specific loop where we were using a QMutex, and we could actually afford to use lock-free programming because, as we will see later, we cannot always afford to do that. The counter side is that it's extremely harder to do, and it's very easy to get wrong. But, I mean, this is not a talk about lock-free programming. I mean, people, maybe not just me, because I'm probably not the best person to talk about that, but we can talk for hours about this topic. I mean, we are interested in just one thing here, reentrancy. Why? Reentrancy is, first of all, not thread safety. This is something I always want to stress because people sometimes get it totally wrong and start thinking, oh, this is reentrance, so I can do everything I want. No, 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 no. But reentrancy at least allows us Actually, the other way around, real implicit sharing allows us to be fully reentrant, which means that implicitly shared classes can be thrown around threads with different datasets. How do we do that? Atomic reference counting. And this is where atomic integers are extremely important in concurrent programming. So this is a very basic implementation of a potential equals operator in a class which is implicitly shared. So what do we have here? Our data member, which is a shared member, has an atomic int as the reference counter. Now, qatomic integer, which of course is the type of atomic int, has two neat functions, which are actually meant for implementing atomic reference counting, ref and deref. These two operations are guaranteed to be atomic all of the times. And in this case, we can simply use this without locking. I mean, if you were to lock this, for example, qstring in Qt is an implicitly shared class. Now, can you start wondering what will happen to your performance if you had to put a mutex every time you copy a string? I will just leave that to your imagination, but I guess you will be barely able to use your desktop. And this is why in Qt 3, qstring was not reentrant, because, I mean, there is always a line you have to draw between performance and features. And back in Qt 3, we were not able to do reference counting these ways. Okay, it was a long time ago, but still. And at that time, we decided not to use implicit sharing and declare it as reentrant. So basically, qstring was not reentrant, or not completely reentrant, as Qt 4 qstring is. This means that you can pass around a qstring around slots, signals between classes, and be guaranteed that always the right copy will be passed, and the reference counter won't go completely nuts when you start messing with threads. This is a very important thing, which you should also look forward to use in your classes. In Qt, qShareData, which is the main feature you use for doing implicit sharing, already has this thing by default. And basically, the reference counting is already implemented for you. But in case you need to build your own thing, just remember to use qatomic integer. So, but this is just a very basic usage of it. Qatomic does much more than that. It supports fetch and store, fetch and add, test and set. So if you know about atomic programming, you know what I'm talking about. And most of all, it implements several different memory semantics. So memory ordering semantics, sorry. So basically, you can do pretty much anything you need to do. And most of all, you always have an indication whether the operations you're trying to use are actually implemented natively using the atomic CPU instructions. This is extremely useful if you're doing cross-device development. So you can always check through macros, so you can even exclude that at compile time. This is very clever. I mean, it clutters your code, but you always have to do one check less when doing an atomic operation. It means a lot. So you can compile stuff out, or you can simply check at runtime. There is both a function for checking that and a compiler maker. Very interesting. But most of you are probably not interested about reentrancy. What about thread safety? So what is the very obvious way of doing stuff thread safe in Qt? Signals and slots, surprisingly. Signals and slots are actually what you use for everything, and guess what? They're thread safe as well. So what's the catch? I mean, most of you are Qt developers, so this thing should not be anything new to you. But maybe not all of you know that this function you're using is completely thread safe. And it doesn't end here. It goes much beyond that, because maybe you don't even know that you can connect a signal to a slot using different connection types. So there are mainly two things which we have to consider. The first one is direct connection. So if you use a direct connection, the slot connected to the signal will be called immediately. So not even passing through an event loop. But there is also a queued connection. What is a queued connection? It posts an event to the thread of the other object. So instead of having a function call, you have an event which is handled as if it was a slot. Of course, you don't know anything about that, because most of you simply rely on the automatic connection, which is the fifth argument you never use to your connect function. And we also have blocking queued, which is sometimes useful, but it's never used by default, because automatic always relies on direct or queued. But blocking queued basically blocks the current thread until the event has been posted. It's quite useful if you do some specific stuff with threads, but very dangerous as well. So, the most interesting thing here is that if object 1 and object 2 are living in different threads, the slot will be called as an event. But what is an object thread? Key object affinity, a thing that everybody should know and not everybody does. Actually, not a lot of people do. Every queue object belongs to a thread, and every queue object lives in a thread. Have you ever got a very, very strange warning on your command line, like cannot create a parent of an object which lives in a different thread, or something like that on your command line? Okay, this means that the affinity is wrong. And you will be surprised to find out that what I said at the beginning of this talk is the very reason. So each member of a parent-children tree belongs to the same thread. And this is why you get the warning, because you cannot create a children in a different thread from the parent's one. You will get a warning, you will be able to do that, but at this point your application, it's really, really a sandcastle. It can go down any minute, because queue objects are always very strict on thread safety and reentrancy. And in this case, you are putting Qt in a situation that is not going to handle for you. And of course, an object belongs to the thread it's created in. Now it's trivia time. After I told you all of this, so do you remember I said that QThread usage with subclassing is actually dangerous? I mean, after everything you've learned, is anybody able to tell me why using a QThread by subclassing can be very dangerous? Does anybody know the answer? You.
Often the QThread object belongs to the parent thread.
And you are correct. We have a winner. QThread does not live in the thread it creates. You're actually 99% correct, because this happens every time. So, why? Because QThread is able to start a thread, but the object, when it's created, belongs to the same thread because the other one never exists. So, just make a simple conclusion. A queue object belongs to the thread it's created in. Okay, we all agree on that. If object 1 and object 2 live in different threads, the slot will be called as an event on the object and on that thread. Stop it. Okay, thank you. We were actually here. And the conclusion is that if a QThread subclass contains a slot, it will be called on the wrong thread. Boom. And this is where your application is probably crashing. And this is where you get the warning, because you're creating in a different thread an object which is parented to the thread which lives in the parent's thread. So this chain brings you to failure, basically. And this is why QThread is extremely dangerous if not used in the right way. So, can we change the object affinity? The answer is yes, luckily, because otherwise we will be in very big trouble. Oh my god. Sorry again. So the function, as you see without the presenter mode, is QObject_move_to_thread. What does it do? It can be called on any queue object using a QThread as an argument. And what it does, it's basically moves the object to the different thread. So I read the question on your face, how to use QThread. Is it useful? I mean, why don't they delete it? It's dangerous. It makes my application crash, it gives out warnings. But no, it's actually not like that. Because QThread is not pure virtual anymore. This means that you don't need to subclass QThread. This is the correct QThread usage that you will never see at the moment in the documentation, but they are going to work on that. So we're creating a class with event loops and slots. I didn't put the constructor because the line was slightly too long, but you get the point. And we're creating a QThread without a subclass, so a pure QThread parented to this object. The other one is not parented, so object is created without a parent. And here is the key. Object move to thread. We are changing the affinity of the object we just created to the new thread we are creating. And we are basically having the object use a delayed constructor which starts whenever the thread exists, because otherwise we will get crashes everywhere because it will try to do stuff in a thread which doesn't exist. And I mean, this is utter failure. And simply, we start the thread asynchronously. What happens when the thread starts, the other object starts, and at this point, the object lives in that thread, and it's very happy to be. So, just put this in your mind, because if you were using QThread by subclassing, you should do that instead. You should move your class out of the QThread subclass. You just need to remove a single line in your class declaration and create it with a different name if you want, maybe not like that, and instantiate it like that. It's just 4 lines of code more, but maybe you will fix a lot of bugs without even knowing. So let's try to do a small recap about what we discovered today about threads and Qt. QThread. When do we use QThread? We use QThread if we need an object to live in a separate thread. This includes the object and all of its children. Once an object lives in a thread, it can create children which will live in the same thread and do anything you want. QRunnable. QRunnable is great to perform an action, whether simple or complex, in a separate thread, without hassle, without anything. So you can simply rely on a single function. You can even use Qt concurrent run for that, which I did not talk about intentionally because I really want people to use QRunnable, which is much safer. And last but not least, actually last but first, Qt concurrent, which is probably the solution to all of your problems when it comes to multithreading. Perform the same action on a set of objects. This is probably the best feature in Qt in regard to multithreading. So now that you know that, you should really go and fix your code, because I'm pretty sure that many of you should. And given that I still have a few minutes, I also want to show you something. So I've been talking about all this QThread thing, but the nice thing is that it's actually all real. So we have this thing here I'm going to show you. Hello, you're here? Nope, you're not here anymore. Okay, you're here now. So what is this thing besides being slightly creepy? It's actually an implementation of multiple OpenGL scenes using threads. So everything you see in every single widget goes in its own separate thread. We can start as many threads we like. All of these are independent. We have this weapon buffer routine happening in a separate thread. Now this is actually running on forwarded X, so 3 threads are too much for my PC, but it should be okay. It basically uploads textures in a separate thread. It makes OpenGL way faster, and it does not block your application, which is probably the thing you care most about. But besides showing you this creepy thing, which I think it's enough, I wanted to show you some portions of the code of the example. I choose this example because it's actually included in the main Qt distribution. So the first thing you should notice is this. Okay, so basically when we are creating a new thread, here we go, what are we doing? We are creating this new GL widget. Now, you probably see that there is no mention of threads at all. Let's just switch to the constructor. Here we go. Surprise, surprise. What is that? Exactly what we have just seen. So, even in these routines, the use of QThread is incredibly important, because of course you need a full-fledged object with just complex things, which has children and everything else, doing a lot of stuff. But we are using the approach we've seen before. So we are moving an object to a thread which already exists, and we are connecting the started signal of the thread to the start signal of our object, which is to the start signal of the thread, sorry, which is basically making everything run smoothly. And everything you see, I mean, for example, these things here are always done on the thread. The fact of separating the thread logic from the object logic is extremely interesting, because you don't have to do actions on your objects directly, but you can simply act on your thread. You're not interfering with what the thread does. This is actually even safer when subclassing, because you might be doing something strange with the object properties of the thread, or you might be connecting some signals to some other slots, or doing any kind of crap you might do when you're dealing with very complex multi-threading appliances. You can simply use this member function straight on the thread instead of straight on your object. And this is pretty much it. We have another thread here in main window. So the GL widget and the painting and the painter itself are running on 2 separate threads again. And I really urge you to have a look at this example, because first of all, it's a great way for finding out how OpenGL can be threaded in Qt. And most of all, it showcases a very good usage of QThread. So if you want to have something to think about after hearing all of these things about threading, about methods of doing threads in Qt and whatever else, you probably should resort to this example. It's called GL Hypnotizer. It's in the demos folder of the main Qt 3. And that's pretty much what you should do. So I really hope you enjoyed this last demo and this last code. And after my kind invite of fixing your code again, I want to thank you for listening. And if you have questions, don't be shy, because I'm here to answer.
Thank you very much, Dario.
You're welcome.
Well, we do have a couple of minutes for questions, and I see one hand up, and then I see two hands up. So we'll start over here, and then we'll go over there.
Can you only have one Qt thread operating on each GL widget, or can you have multiple threads on a single GL widget?
Very good question. Now, this answer is slightly more complicated. The GL widget is living in a separate thread. So the GL widget is a thread, actually. That's the point. But you can have basically one single thread acting on it and multiple threads doing other functions. So you should keep your logic. There is a very, very good blog post about Qt and OpenGL multithreading. I will just give you the link later. But basically, you can do buffer swapping in a separate thread, texture uploading in a separate thread, and painting in a separate thread. That's the three main things you can do. So there is a painter thread. That's the most interesting thing probably. So QPainter can be used in a separate thread. The catch here is that on Linux, you need to initialize threads for X11. So there is a parameter you have to create in your constructor or your main function, which is basically just set attribute X11 init threads. That's everything you have to do. And this example is very good for that. I will give you the link to the blog post, which actually is explaining everything in a much better fashion than I am doing now. But yeah, pretty much you should always resort to one single main thread and other threads for doing separate operations. You're welcome.
So a couple of questions if there's time. First, with Qt Concurrent, if it's been around since Qt 4.4, how come it's been used hasn't been used more than it has, say, in KDE or by KDE?
And that is actually why I'm giving these talks. The answer is in the question, because it's not being advertised as it should. In KDE itself, I'm trying to push it wherever I can. But of course, KDE is huge. I mean, it's incredibly huge. And of course, there is room for improvement. And if you like to do this optimization, you can just take the ball and start implementing these things on your own. But I agree with you, it should be used more. And we need to make people aware of that. So it's a very good question, but the answer is you. You have to do that. We have to do that, all of us.
So also, in terms of Qt Quick, especially Qt Quick 3D and OpenGL and threading, are there any problems that can come about using these thread implementations?
So your question is basically if the threaded OpenGL I've just showed you is somehow playing nicely or badly with QML3D.
Yes.
If I understood you. Okay, let me say that I don't never will answer to this question, to be honest, because I'm not following the QML3D product. But just out of the top of my head, it probably is doing these things under the hood. So the feature I'm showcasing, it's in the master tree of Qt because it has been introduced in Qt 4.8. It's not really a feature, it's more like you are able to do that. Because before that, all the GL functions were actually fully re-entrant. So again, this blog post that I was directing your friend to is actually containing a whole analysis of the previous situations and why you could have done that before, but why it would not have been a great idea. So this really depends on the backend QML3D is based upon. I suppose that Qt people are investigating this solution for basing it on QML3D, but again, this is just my personal rambling because I don't know anything about it. This is just my idea of the whole thing. But you're probably welcome to ask these questions on Qt Interest, which is the mailing list for Qt development and whatever else, and get an answer over there.
There is indeed one further question. And I'll just run around the corner there.
Hello, Sarah.
If people have got questions about Qt 3D, I can probably answer them afterwards. I'm the team lead of that project.
Perfect. Yeah, in fact, I was about to say, but I was not sure if you wanted to.
Basically, because it's cross-platform, you don't always know that you have X and X-Render and all of the XGL extensions. Some of them are direct frame buffer, so you don't always have the
Yeah, exactly.
threading.
As I told you before, the thing for actually initializing threads on X11 it's actually the reason why we didn't have this before. So in Qt 4.7 you won't find that option. And at the same time, something I didn't say, and I probably should have said, is that everything you've seen is actually working on OpenGL2 or OpenGL2 ES. Anything but that, not going to work, so you have to be careful. I mean, you can always check for capabilities of your system, both at compile time, both at runtime, but be sure not to do crap with OpenGL, because it's very, very happy to crash your application in so many different ways and so many nice ways.
Okay, is there any further questions? If not, put your hand together once more for Dario. Oh,
Thank you.
telling us how to do multi-threading properly with Qt. And as a small token of our appreciation, we have a gold-plated glass penguin.
Thank you
there we
very
go. Okay, thank you very much. And that's it for the day from Linux Conference Australia 2012. Pace yourselves well, because you've got a few more days to go. Okay, thank you.